This is Algebra 2 at Trig, 8B.1. We're going to talk about angles in standard position and coterminal angles. So first we're going to talk about what is standard position. That's when we have a vertex at the origin. We have one side called the initial side on the x-axis. And then we have this other side that we can spin around. This is called the terminal side. So in a coordinate plane, an angle can be formed by fixing one ray, called the initial side, and rotating the other ray, called the terminal side, about the vertex. An angle is in standard position if its vertex is at the origin and the initial side lies on the positive x-axis, just like our demonstration shows here, our diagram. Remember that the initial side is always pointing to 0. It's always 0 pointing to the right, the positive x's. And then we start to bring around this terminal side, and here it is, larger than 90, but less than 180. You might call that 150 degrees. So when we do positive angles, if this is 0 degrees, and straight up, we kind of make a box in the corner, so we'd call that 90 degrees, and another 90 makes 180. So we are going counterclockwise. That is in the positive angle direction. So a negative angle is going to go in the opposite direction, which would be negative. You could also be negative if you just kept going. You could go around more than one time. But the point is that we are going clockwise. That is going to be a negative angle. So let's practice drawing a few of these. What is a 135 degree angle going to be? Well, we know this is 0 degrees. This is 90 degrees. 90 more would put you at 180. So 135 is going to be short of 180. If we went from 90 to 180, if we just went halfway, that would be 45 more degrees. That would be here, halfway down the center. 45 degrees extra. And that happens to be 90 plus 45 happens to land exactly on 135. So that would be a good approximation. You want to do the best that you can at drawing your angles as accurately as possible. Having it too close to 180 would make that angle no longer being very accurate at 135, or making it too close to the y-axis, close to 90 degrees, would make it somewhat inaccurate. You want to do your best at mimicking what the degree value would be compared to the axes. 640. I'm not sure where that is. Well, I know that this is 0. And if I go straight up, I get to 90, and 90 more puts me at 180, and 90 more puts me at 270, and 90 more puts me at 360. We're all pretty aware of that 360 all the way around. 90 more would put us at 450. And 90 more would put us at 540. And 90 more would put us at 630. So 640 is going to be 10 degrees past that. So if we're 10 degrees past that, we would then be at 640 degrees. It's just an approximation, but we definitely wouldn't be here in the third quadrant, and we shouldn't be very close to the halfway point between coming all the way up to 720. Negative 105. Well, if this is 0 degrees, we'd be at negative 90 degrees if we came down, and negative 180 degrees if we came over there. At the halfway point, which would be 45 extra, that would be negative 135. So I'm going to be short of 135. I'm going to be down here at negative 105. Just an approximation, but we can be pretty accurate with our approximations. Now we come to coterminals. Coterminal angles are angles whose terminal sides coincide. That means they point in the same direction. They can be found by adding or subtracting multiples of 360 degrees. So if we're going to find a positive and negative coterminal of negative 215, let's first do the geometry aspect to it. Let's do a little sketch to see where is negative 215. Well, again, this is 0, this is negative 90, this is negative 180, this would be negative 270. So I know I'm over here in the second quadrant somewhere. I seem to be 35 degrees past the x-axis. That would be negative 210. Well, if I'm going to continue in that negative direction, what other angle would point in that same exact direction? If we take our negative 215 and we continue in the negative direction, we can do that and see that it would be negative 575. Now, what other angle could also point in the same direction? Well, we could continue in the negative direction and keep subtracting. But if this is our negative answer, a positive answer, we would need to add 360 degrees. And when you add 360 degrees, we get 145 degrees, and that's our positive answer. We're looking for one that's negative and one that's positive, pointing in the same direction as our negative 215. Now for 570, I like to draw out the angle first. This again was 0. And then we went to 90. We're going in a positive direction. 180, 270, 360. This would be 450, 540, and 30 extra degrees would point you in that direction. So we went around a full time, and we went around into the third quadrant after that. What other angles point in that same direction? We have 570. So if I back up 360 degrees, I'm still going to land at that coterminal location. I'm at 210 degrees. That is a positive coterminal, because we're asking for one positive and one negative. That would be my positive answer. Now, could I have added 360 to 740, 570? The answer is yes. I could have added 360 to that. Now I'm going to take my 210, which is pointing in that direction, and I'm going to subtract 360 from it again, and that gives me a negative 150. That's my negative answer. And that makes sense, because if I'm down here in a negative direction, I'm going to be more than negative 90. I'm going to be less than negative 180, and I'm 30 degrees off. So that is 30 degrees less than 180. So now with these three, you go ahead and give it a try. Pause the video, try these three, then come on back and see how you did. Yes?
So when you're trying to find the negative coterminal, like with that one, it was 570 minus 360 got you 410. Are you allowed to just do 570 minus 720 because you already know the 360 isn't going to be?
You're just being fancy pants, and that works.
Okay.
Yeah. You'll probably use the 210, and then you just minus it from the 210. But mathematically, it is the same answer. It's still recording. So if we're pointing in the 65, which would be approximately this direction, we want to continue in that positive direction. So that's going to be 65 plus 360, which is 425 degrees. That would give us a positive answer. We want one positive and one negative. So our original was 65. Now if we go in the negative direction, we're subtracting 360 from there. That puts us at a negative 295 degrees, which is our negative answer. So now we have one positive and one negative coterminal to the 65. Negative 130. Down here would be negative 90. Over here would be negative 180. I need to be 50 degrees short of the 180. So it would be approximately off in that direction. Now if I continue going in that negative direction, I'd be subtracting another 360. So that's 490. Negative 490, and that's a negative coterminal. If I take my negative 130 and I add 360, I'm going to get 230. And that's my positive coterminal. 230 would be more than 180. It would be 50 degrees more than 180, just like we said the negative 130 was 50 degrees short of negative 180. All right, last one, 740. Well, where is 740? This is 0, this is 90, this is 180, 270, 360. Probably learned those patterns by now. Another 360 would put us at 720. Well, 740 is going to be 20 degrees more than 720. That's 740. So if I take my 740 and subtract my 360 from it, I'm going to get 380 degrees. That would be a positive coterminal, no doubt. But I can subtract another 360 from that, and I'm down at 20 degrees. I'll call that my positive answer, but they both are positive coterminals. But now I have to subtract 360 degrees again to finally get into the negative zone, and that would be negative 340 degrees. That would be my negative answer.